solve question based on this particular fundament, right? Now let us move on to the next agenda, that is solving of linear equations or finding out solutions of linear equations. Let us put the heading of solution of linear system of equations. Solution of linear system of equation. This next heading, which is saying solution of linear system of equation, right? So we have two types of equations which we can see: linear equations in two variables and linear equations in three variables. Linear equations in two variables are very simple to solve. For example, if I say there are linear equation a1x plus b1y plus c1 is equal to 0. See, equation is said to be linear when the degree or the highest power of any variable is 1, right? So linear basically represent 1, right? Or you can say, what is this 1? The degree is 1, right? So a1x plus b1y plus c1 equal to 0, and they'll say there is another equation a2x plus b2y plus c2 is equals to 0. Now we have studied in our earlier standards, small when we were kids, that these represents basically straight lines, and in fact a pair of straight lines. So this pair of straight lines can be in three orientations. Number one, they can cross each other at a certain angle. Number two, they can be parallel to each other, and number three, they can have overlappings. So when I am talking about this, that means there will be an intersection point, and we can say these points will have a unique solution. I am talking about solutions, right? In this second case, they won't have any solutions, so they will have no solutions because they are parallel, they will never meet. And in this case, you will have infinite many solutions because they are overlapping, so they're meeting at every point, right? So if I say a1x plus b1y plus c1 is equal to 0, this is one equation, and a2x plus b2y plus c2 is equal to 0, so they can have either a unique solution or a no solution or an infinite solutions, right? Now based on certain conditions, based on the values of a1 b1 c1 and a2 b2 c2, I can say that whether they will have unique solution, no solution, or infinite many solutions. So let us take it out first. Let us say, if I say, when you talk about unique solution, so it will become a1 by a2, the ratio of coefficients of x, if it is equal to, not equal to the ratios of coefficients of y, that is b1 by b2, then we will say it is a case of unique solution. And if the ratios of coefficients of A is equal to ratios of coefficients of B but not equal to ratios of coefficients of C, then it is a case of no solution. And when all the three, A1 by A2 equal to B1 by B2 equal to C1 by C2 are equal, then it is a case of infinitely many solutions. This is very, very important. Sometimes in your aptitude part also, questions on linear equations are asked in the chapter of algebra, where also you can also comment on linear solutions of two variables. Right? This is for two variables because two variables represent a straight line, right? Also say you can divide this into consistency and inconsistency. This is called as consistent solution. Consistent means we will get a solution. Inconsistent means we won't get a solution. Inconsistent, right? And here also it will be consistent, though it is many times consistent, but it will be consistent. Consistent means that you will get at least one solution, right? So you can say both cases, unique solution and infinite solution will give you consistent solution, and when you talk about no solution, it will give you inconsistent solution. Okay, so this is talking about solution of linear equation for two variables, but many a times we have to deal with three variables or maybe more variables. So when we talk about more variables, or let's say three variables, then this thing will fail. And what we have to see is we have to form we have to take help of matrix or the matrices. Let's say the equations are something of the kind a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3. Let us say this is a system. This is basically a system which I was talking about. This x, y and z represent some parameters like temperature, pressure or something or the other, right? And combining this effect, the complete effect, the output is coming out to be d. Getting my point? This is how a practical system can be defined into a form of a mathematical equation. This is a practical application. Similarly, when we study about differential equations are nothing but change in y with respect to change in x. Dy by dx is nothing but change in y with respect to x. So y and x are some parameters. Change in volume with respect to time. Dy by dx, you can say dv by dt, change in volume with respect to time, right? So this is how basically the systems are defined, right? So now I'm coming back to this thing. So when d1 d2 d3 are 0, when d1 d2 d3 are 0, those types of equations are called as homogeneous equations. Those are called as homogeneous equations. Getting my point? And when these are not equal to 0, so we call it non-homogeneous. You can say d1 equal to d2 equal to d3 is equals to 0, and here we will call it non-homogeneous, where d1 not equal to 0, right? So if all the three are 0, then it is homogeneous, otherwise they are non-homogeneous. In fact, you cannot say that these are not equal, but uh, otherwise you can say, if this is case then homogeneous, otherwise in all the cases you can say all other cases this is non-homogeneous. In fact, 2 can be 0. If d1 d2 are 0, d3 will not be 0. So that is a case of non-homogeneous, right? Any of the d1 d2 d3 is not equal to 0, then you can say it is non-homogeneous case, right? Now when you talk about homogeneous, it is very simple. Here you will never get condition of inconsistency. It will never happen. The solution will be always consistent. So first point I will say is no condition of inconsistency. It will always be consistent, right? It will always be consistent. Second, if the rank of A, the matrix A, is equal to the order, right? For example, if I say the rank is R and the order is N, then this is a condition of unique solution. This is a condition of unique solution. When I am talking about rank, can rank be greater than the order? No. Yeah, we have already discussed about rank. Rank of A is less than the order. Rank of A is the less than the order, or I can say R is less than N. Then this is the condition of infinite solutions. So first thing we said, no condition of inconsistency. You will never find inconsistency. That means there will always be consistency. Now consistency can be two types, unique as well as infinite. So unique and infinite consistency you can find out if R is equal to N, that is the rank of A is equal to the order of A, then you can say it is unique solution. And rank of A is less than the order, then it is a infinitely many solutions, right? Similarly, when you talk about non-homogeneous, right? So non-homogeneous case, we will also define something called as augmented matrix. Augmented matrix, which is defined normally by A augmented B, right? Where B is nothing but d1, d2, d3. B is nothing but d1, d2, d3, right? For example, in the above case, you know, when we're talking about the above equations, these equations we will say, right? Let's say I'll take the marker. These equations we are talking about. So here the augmented matrix. In this case, the augmented matrix will become A oblique B, which can be represented as A1, A2, A3, B1, B2, B3, C1, C2, C3, augmented with D1, D2, D3. This is the augmented matrix A oblique B, right? We'll solve questions, you'll understand it much better. But just for understanding, consider that there is something called as augmented matrix. So when we talk about condition of inconsistency, then the rank of A is not equal to rank of A augmented B. Simply, when the rank of A is not equal to the rank of A augmented B, then simply you can say that it is inconsistency, or you can say this is a condition of no solution, right? In the second case, consistency, when I say rank of A equal to rank of A augmented B also equal to the order of A, then this is a condition of unique consistency or unique solution. Clear? There are certain conditions, okay? Then if you talk about the third case, if you talk about the third case, right? What is the third case? Third case is rank of A is equals to rank of A augmented B and is less than the order. Then it is infinite many solutions. It is infinite many solutions, right? It seems to be very confusing right now, but when we'll start solving the questions, it is really very easy for us to understand how we can understand these things. For a time being, just understand these conditions and we will discuss these questions so that it becomes very clear for us to get this particular thing, right? So now let us understand this with an example. Let us take a understanding of a gate problem on this, right? Let us talk about a problem which appeared in 2010 of a gate paper. The question was something like, for the following set of equation, the equations were x1 plus 2x2 plus x3 plus 4x4 is equals to 2, and the other equation was 3x1 plus 6x2 plus 3x3 plus 12x4 is equals to 6, right? Now there are four variables, that means there can be four parameters: temperature, pressure, volume, and let's say time, for example, right? So this is how I'm correlating practical with the theory sort of a thing, right? Okay, now let us look at the options also. And what was the question? The question was, the following statement is true. Which of the following is true? You can say which of the following is true. Option number one: only trivial solution x1 is equals to x2 is equals to x3 is equals to x4 is equal to 0 exist. Trivial solution means that all the variables are 0. That is meaning of a trivial solution. Second, there is no solution. There is no solution. That means he's talking about inconsistency. First tell me whether these two equations which we are talking about are consistent, or sorry, not they are homogeneous or non-homogeneous. Very correct, they are non-homogeneous because d1 and d2 are not equal to 0, right? Third option which was given to you is a unique non-trivial solution exists, and the fourth option which was given to you is multiple non-trivial solution exist, right? So when I talk about this particular cases, right, let us first draw the matrix. What is the matrix? When we'll start solving this, we'll first draw the matrix. So what is the matrix looking like? Let's say I name the matrix as A. It'll be 1 2 1 4 1 2 1 4, and here it will be 3 6 3 12, right? And let us say this is B, which will be 2 6, right? Now this actually, if you want to convey this thing, you can say this is of the matrix of, let's say, something like A x is equals to B. This is basically the definition of non-homogeneous, where A you have seen is given, B is given. What is x? X is basically, x is nothing but your variable, set of variable x1 x2 x3 x4. So when you multiply A with x, you will find 1 into x1, 2 into x2, 1 into x3, 4 into x4 equal to B. B will be giving you 2. So we can correlate that thing, right? Okay. And so if you go through this, and also because it's a non-homogeneous, we also have to define something called as augmented matrix, A augmented B. And this A augmented B will look like, you have to first represent A matrix and augmented B matrix. So this is the A augmented B. So I just represented A, B, X and A augmented B. Now let us check the conditions, right? Now if you see, for the matrix A, right, uh, can you find out the rank of A? For A, by row eliminations, right? For A, you can say by row eliminations, by eliminations, can I say that R2 tends to R2 minus R2 tends to R2 minus R1 in A. I'm talking about in matrix A. So A will become what? 1 2 1 4, R2 minus, not R1, you can say, you take it 3 times R1. So this will become 0 0 0 and 0, isn't it? So what is the rank? So rank of A, you can say, is 1. Rank cannot be 0, right? Number of non-zero rows, we can say. Similarly, same eliminations in A augmented B. In A augmented B matrix, let us say R2 tends to R2 minus R1. So A augmented B will become what? It will become 1 2 1 4, and here it is 2, and this will become 0 0, not 3, sorry, not R1 but minus 3R1, right? Here also, when we are saying let me complete this. When we are saying it is minus 3, and here also it is minus 3r1, and this becomes 0, this becomes 0, and this is also becoming 0, right? Clear? So again the rank here I can say about A augmented B will be how much? The rank of A augmented B is also 1. Now let us look at the consistency. So you know that finally we can say that rank of A is equal to rank of A augmented B. That means it is a condition of consistency. Now whether it is equal to, that means the option number C and option number D can be your answer, right? Now whether it is equal to the order or is less than the order. The order was 4 cross 2. You know, I'm not saying about the order. Order here in this case will be the minimum of the row or the column. So order is 2. My n or the order which I'm talking is not the order of the matrix, it is the order of the highest cofactor you can form, highest minor you can form. That is 2, right? 2 cross 2. So, so rank of A augmented B is less than n. And this is a condition for what? Yes, consistency with infinite solution. So you have consistency with infinite number of solutions. So you can say that if the consistency with infinite number of solution, that means you can say that option D will be your answer, which is saying multiple non-trivial solution exist. Clear? So this is very simple for us to understand in this particular format, right? Let us take another example which will make us very clear on how to go about these kind of questions, right? Let us take one example which is was asked in 2003 of gate paper. Let us solve that particular thing. Question from gate 2003, right? The equations were given something like x plus 2y plus z is equals to 6, 2x plus y plus 2z is equals to 6, and x plus y plus z is equals to 5. And you were asked that this system has a unique solution, b infinite solutions, c no solution, and d two solutions, right? So let us form the matrix first. Matrix will be of A will be 1 2 1 2 1 2 1 1 1. B here will look like 6 6 5, right? And when we are talking about A augmented B, we're talking about A augmented B matrix. A augmented B will look like 1 2 1 2 1 1, sorry, 2 1 2 1 1 1, augmented with 6 6 5, right? So this is how this will look like. Now I'm solving directly the A augmented B. So whatever operations I'm doing, I will do it with A also as well as A augmented B also. So now row elimination I'm using, I'm saying that R2 tends to 2R. Ultimately my job is to find out the rank of A and the rank of A augmented B. So I'm using eliminations and I'm trying to find out this, and I'm saying that R3 tends to R3 minus R1, right? R2 tends to R2 minus, sorry, it is basically R2 minus two R1 and R3 tends to R3 minus R1. So the augmented matrix AB will now look like, first row we are not changing at all. Second row R2 minus 2R1, so it will become 0. This will become 1 minus of 2, that is minus 3. This will become 0. This will become minus 6. And similarly we are saying R3 minus R1, so 1 minus 1 is 0, 1 minus 2 is minus 1, and 1 minus 1 is again 0, and 5 minus 6 is minus 1, right? Still I can see that what I'm trying to do is I'm trying to make the R3 to be 0, so that if it is case which can be 0, right? So if I use another elimination, and if I say that now I say R3 tends to R3 minus R2 by 3, right? So this becomes 1 2 1 6, 0 minus 3 0 minus 6, and 0 0 0, and this becomes 1. Now what can I comment about the rank of A? If I see only the A part, this is the A part, right? So if I say the rank of A is nothing but 2, the number of non-zero rows, and rank of A augmented B is coming out to be how much? I can say 3 because there are 3 non-zero rows, right? A augmented B having non-zero rows as 3. So the rank of A is not equal to rank of A augmented B. Which condition it is? This is a condition of inconsistency. Very correct. Very correct. So where we can say that rank of A is not equal to rank of A augmented B. So this is a condition of inconsistent solution. Inconsistent solution of the non-homogeneous equation. So you can say your answer will become option number, what was the option if I'm not wrong, it is option number C, that is no solution. Option C you will say, or will be your answer, inconsistent solution, or you can say no solution. So similarly you can find many of the questions in your gate papers, in your assignment booklets. You will find a lot of questions. The books provided by ICE Academy, you can now start solving them in terms of